Greetings, ladies and gentlemen. Today I will be running through tutorial questions and their solutions with you. This is with respect to properties of plane areas within Mechanical Design 238. The levels will slightly get more difficult as we go through these tutorials. As mentioned previously, these questions were devised purely by Dr. Nazrul Islam from the Department of Mechanical Engineering at Curtin University of Western Australia. So let us get started today, shall we? The question itself, same as previously, but this time there's a bit of a change to the question as we are given two lines this time rather than one. Okay, so instead of the single function given here, we're given one function this way as another function going that way as well. So the question is slightly different this time around. Okay, so as I said, like always, there's a variation in questions. So as we get started, we want to find the area before we do anything within the integration method. So before we actually get started, we want to find the actual equation of this line right here. There's dotted lines illustrated on that function right there, and this will equal y mx plus c. This is the general formula for a line. And to figure out y equals mx plus c, we need m, the gradient of the line, which is 1 over half, which is 0.5. This would equal 2. Okay, and we substitute the respective intersecting points here, or the given point on the line where the gradient ends. And this intersecting point here with both functions here is 1:1, where we substitute into this equation here that we devised 1 equals 2 plus c, where c equals -1. Okay, the function of that line is y equals 2x takes 1. Okay. Now that we have that equation, we want to find k, the constant here. We never want to leave the constants lying around like that, so we want to get rid of them. Substitute the 1:1 again, as it is the intersecting point here, the point given along the line. Any point given, you can find a constant in the equation. So we go y equals 1 equals to the function of kx to the 1/3, where k is unknown and x is given as 1 again. 1 to the 1/3 is still 1, where k equals 1. The function of this line is y equals x to the 1/3. So that is terrible handwriting right there. So x to the 1/3. Okay. On the graph over here, we're given a shaded area, and we want to find the centroid of this shaded area. Now, how would we actually go about this when we have the centroid lying right here, close to the function below? Here is a problem, because if we try to take a strip like this and we take the area dA here, remember that this strip area is dA as mentioned in my previous video, the dA would not be as accurate, because this area here, we don't know where it exactly ends or where exactly it begins. So to avoid all these discrepancies, we want to take area and the strip from another direction. And as you guessed correctly, the direction is this way. This would slightly change things here. First of all, is no longer dx. Dx as a general direction anymore. It is dy as the general direction, where yc or y equals y. It no longer equals y2 plus y1 divided by 2. Okay, so when we look at x will be like y previously. Okay, so now x equals x2 plus x1 over 2. Okay, as illustrated from the previous video. Okay, so now things change quite a bit here. Let's just quickly write out the equations now. X equals x2 plus x1 over 2. Y equals y plus dx, y plus dy on 2. Where dy equals 0, as you remember from previous video, y equals y. Simple as that. Okay, so we're given, we've worked through all this in information. You know, we've got a few different points about our question now, and the different point is we're basically inverting our question now. We're flipping the things sideways, and we're working through a different direction now. We're no longer working with x's and y's; it's more like y's and x's. Okay, so what happens to our equation here? dA is simply the opposite. It's just going to be x2 takes x1 dy instead. So this is going to be the integral for y, not x anymore. Okay. So work out quickly. Let's just work out what does x2 equal to. X2 is simply transposing for x in the above equation here. Okay, so let's just quickly transpose. X equals y plus 1 over 2. Okay, x2, that is, sorry. x1, just quickly write it up here. x1, sorry about the cram of all this information in one corner, but just don't have room. x1 equals y to the power of 3 as transposed from here, and I'm sure you know how your indices by now. dA, so area of the shaded section here equals the integral between 0 and 1, as you can tell from 0 and 1. Same thing as before, but just imagine looking, instead of looking directly vertically at the graph, you're just going to tilt your head horizontally and you're going to look at the graph like that now. Okay? Now, because of the change of axes, as you can see the change in the formula as well. So let's just quickly substitute 2x takes, sorry, my bad. Always make silly errors like that. Okay, that's our equation from here, x2. Okay, subtracts y to the power of 3. Whole thing in brackets. Never forget the whole thing in brackets to the dy. Okay, this is very important because dy is what we're doing it with respect to. Everyone knows the integration. This is basic math here. Y squared divided by 4 raised to the power 1 divided by the new power. Multiply if there's any constants at the bottom. Y divided by 2. And if you have the actual variable on the bottom, things change and you get an ln, a natural logarithmic instead. That's another thing we'll look at later. Y to the power of 4 divided by 4. And we close square brackets, what we are actually working for. And the area now equals, substitute. Obviously, the zeros cancel the y's out, so that we would just ignore that part. Okay, so the 1 on 4s cancel each other out, and you'll end up with area equals a half units, or half squared units. We don't know the units here. It could be millimeters, God knows. So let's actually do the real working out, what we're actually looking for. Okay? The question asks x and y centroids. So we can remember previously, that our function was formula was x, the centroidal x that we were looking for, equals qy divided by area. We just worked out area, haven't we? Which was a half unit squared. Squared units. Where qy equaled the integral a between two limits x bar, x dA. Okay, so I'll see you guys in my part 2.